Alright guys, good morning. This is going to be the part 2 of the Desmos introduction. Essentially, I'm going to start talking about the relevance or importance of the secant line in a calculus discussion. Okay, so what am I looking at? I'm looking at the sinusoid with a linear behavior that is imposed by this term, that 0.3x. Okay, that is the purple graph. And the second thing that I'm looking at is this green line right here. And the green line has 2 points that are specified. Those 2 red points, one that is at x equals 0 and another one that is at x equals 1. Essentially, these 2 points belong to the purple graph or the sinusoid, and essentially this green line creates a linear function that basically is based around the rate of change from x equals 0 to x equals 1. What is the rate of change? It's nothing but the slope, okay? So, in other words, what I'm saying is that I grab 2 points, okay, from the purple line, and using those 2 points, I created a line. You only need 2 points to create a line. You can calculate the slope, and you can also, from one of these points, you can also calculate the y-intercept. Okay, so that was a lot, I know, but I'm going to go through each of these rows, okay? So again, row 1 is my function, my purple function, okay? What is A? A is essentially the first point, so at x equals 0, I'm saying that at x equals 0, I have this point. And how do I get the second point? Well, I just add the distance 1, okay? So I said, okay, well, I have this point, and what if I add a distance of 1? Well, I get this other point right here. And if I wanted to add a distance of, say, I wanted a closer point, so 0.5, okay, so now my distance from my points got smaller, okay, yeah, and I can make it even smaller, 0.3, have a smaller distance, 0.2, have a smaller distance, 0.1, okay, 0.01, okay, so now the distance is very, very small, okay. Alright, so let's go ahead and write it again. Okay, and this fourth row right here, essentially what it does is it calculates the slope. Okay, so because I have 2 points, I just, I write a little code that says, okay, the value of the function at a plus h, which is my second point, minus my original, the value of the function at a, okay, over h. So it is rise over run, okay. And so the green line right here is essentially just graphing that line, okay, and these 2 rows specify the points that I'm working with, okay, so a and a plus h. Alright, so now let's see. I'm going to do a little bit of an investigation right here, okay, because the rate of change tells us a lot of useful information. So suppose, for example, that this is that you're looking at the stock of the trend line of a stock that you invested on, right? It's mostly positive, but somewhere in between there's going to be these like lumps right here. So, for example, on a given day, it increases a lot and the rate of change is a lot. So you want to sell. Maybe you're stuck at that time, okay? So the rate of change essentially tells us whether our function is increasing if it is positive or decreasing if it is negative. Okay. Now, I'm going to choose my starting point at 0.5, okay? That is going to be my starting point, and since I added a distance of 1, my other point is going to lie at 1.5, okay? Now, what if I wanted to be really, really specific and I wanted to know exactly the rate of change from 0.5 to, let's say, 1, okay? So I'm going to add a distance of 1, okay? So the rate of change from 0.5 to 1 is going to be 1.02, okay? What if I wanted to get really close to the rate of change at 0.5? So I can decrease the distance. So let's say that I wanted my next point to be very, very close. So 0.5, 0.3. Okay, so let me see. Okay, so now the distance got really close, and now the slope at 0.5, okay, at x equals 0.5 is going to be 1.093. All right, now if I decrease that distance, I'm going to get, let's see, let's grab 0.1. Okay, so okay, well now my slope is a little bit more specific because the distance from 0.5 to 0.6, because I added 0.1, right, is going to give me a slope of 1.15. And remember, I'm working with the secant line, right? The secant line is a line that touches my function at 2 points. All right. Now, since I want to be very specific about the slope at 0.5, I want to reduce my distance. So what if I did 0.01? Okay, so now I got really close to my original point, and the slope right there, okay, is going to be 1.17. All right, eventually what I'm getting at is that the distance between those 2 points is going to get very small. So look, like for example, let's say I put the distance from 0.5 to 0.5001. Okay, so now the distance between my points is super mega small, and that secant line is going to touch the function at 2 points that are at a distance that is so close. Okay, so my slope is now more specific, and it gives me 1.17. Okay, now when you get to like smaller and smaller distances between those 2 points, you're going to get a line that only touches the function once. And a line that touches a function only once is going to be called a tangent. Okay? And the tangent in a calculus discussion is essentially your derivative. Okay? So like for example, what is a derivative? The derivative tells me the rate of change of my function at a specific value. So let's see, okay. I wanted to know the slope of my function at 0.5, and the slope of my function, or the rate of change, is going to be 1.1775, which is exactly, right, or very close to the slope that we got here. So we got 1.1773. Okay, we're missing the 5 right here, but we made a very close approximation of what the rate of change of the function at 0.5 is. Okay, now I just want to stress the meaning of the rate of change. What does it tell us? Why is it important? Why do we need it? The rate of change tells us whether our function is increasing or decreasing. And it also tells us how fast. So for example, if you have a very huge rate of change, that means your function is really increasing at a huge rate, at a very fast rate. Or if it's negative, it is decreasing at a really fast rate. So to bring it back to that discussion about, for example, stocks, right? If your rate of change of your stock is really negative, then you want to make sure that you either sell that thing before it keeps losing value, or you want to wait it out, right? You want to, for example, wait it for a period until it decreased, and then it shoots back up. Okay, or if it's really positive and it's increasing at a very high rate, maybe eventually it's going to hit a plateau, and then you're not going to be able to make any more money. So you want to sell it at a point that you think is appropriate. So the rate of change tells us when it's best for, or when our function is really increasing or decreasing. How do we know that? We know that rate of change from 2 points, right? And those 2 points can become really close to each other until it turns into a tangent line. And the tangent line offers the very specific rate of change of a function at a given value. Okay? I just want you to be comfortable with the visuals, because then we're going to get into the math, and it's important to come back to this video and watch it again and again until that concept is planted in you visually. Okay, hopefully I didn't confuse you a lot, and you can come back to this video and hopefully understand it in the future. But for now, I hope that this was useful, and that we can continue our calculus discussion in the future.